All right, let's find the real zeros of a, well, find the real solutions of a polynomial equation. Really, that would be finding the real zeros of this function. Got x to the fourth plus x cubed minus 5x squared plus x minus 6. And the tools that I'm going to use are really no different than what we were using earlier. So let's see here. Again, we're lucky with the fact that that lead coefficient is 1, because first we can look for the real solutions that are rational solutions, integer over non-zero integer. So factors of 6, the constant, over factors of the lead coefficient, 1. And since the only factor of 1 is itself, and dividing by 1 doesn't change, then our factors of 6, including the positive and negative, 1, 2, 3, and 6, positive or negative on each of them. So let's graph this equation. Well, graph the function. Let's see here. So x to the fourth, x to the fourth, plus x cubed minus 5x squared plus x and minus 6. Since our list of possible rational zeros, the one with the greatest absolute value, either positive or negative 6. So I'm going to look just a little bit left and right of 6. And again, in the y direction, very narrow view in the y direction that has 0 in between, because if it makes the function 0, i.e. that makes y equal to 0. So I'm looking for x-intercepts. And I've got 2 spots here, -3 and +2, it appears. Those are on the list. So let's perhaps prove that we've got zeros there and therefore solutions using synthetic division. So we're testing x equals -3 and x equals +2. Let's go with a positive one first. 1, 1, -5, 1, and -6. Bring down the first entry, multiply, add, multiply, add, multiply, add, etc. So let's see here. 2, 3, 6, 1, 2, 3, 6, and 0. So x equals 2. That is a rational zero. It's a real zero. Rather than return to where I started, let's now test the -3. 1, -3, 0, 0, 1, -3, and 0. So both of those are rational zeros. They are real zeros. What we found out so far, x minus 2 is a factor, although solving the equation does not directly ask for this. It's not asking for the factors, but it's related information. First, I found x minus 2 times, well, fourth degree divided by a first degree would give me a third degree. So x cubed plus 3x squared plus 1x plus 3 that could have also been factored by grouping. Factor out an x squared here. And a 1 here. X plus 3 is a factor of both groups. So whether by the synthetic division, seeing that -3 is a solution to the equation we started with, where this polynomial equals 0, and x plus 3 is a factor, the other factor, whether by synthetic division or by grouping, we're seeing an x squared plus 1, because again, we're dividing a third degree, a cubic, by a linear first degree. So we're left with a quadratic, something that's second degree, 1x squared plus 0x plus 1. Now, are there other solutions? You could try factoring this x squared plus 1. That's not going to work. You could try completing the square or the quadratic formula, or something actually simpler. Since there's no x in the first term, then you could isolate x squared and apply the square root property, but then, we're taking the square root of a negative number. So we have found all the real solutions when we stated 2 and -3.